Hope you're doing good. Today we are going to talk about the downsides of microservices. What you should think of before you decide to introduce microservices into your architecture. Or if you already have microservices in your architecture, before you add another microservice. First, end-to-end testing is harder with microservices, and end-to-end testing is very important to ensure quality. And this also interplays with continuous deployment. If you have a monolith, you can have an end-to-end test, and if it passes, you can deploy it to production. One or more end-to-end tests. Whereas if you have microservices, a change to one microservice may pass its own tests and go to production, causing a problem for a second microservice in production. Because many bugs occur at the interfaces between modules, not within a module. Refactoring across service boundaries also becomes harder. And design is organic, it evolves. It's not something you do top down at the beginning of a project, like a building. Moving on, provisioning becomes harder. So if you have a microservice A that invokes B, and let's say you have 5 instances of A, would you have only one instance of B? Or maybe for fault tolerance, would you have two? But independent of how many A's you have. Would you have only a fixed number of B's? Would you have one-to-one, one B for every A? But what if you don't need so many B's? Or would you have some ratio? For every 3 A's, I'll have 1 B. If A autoscales, does B also autoscale? Is the policy the same? Are the autoscaling thresholds the same? How do you route requests? In this diagram, it's one-to-one. But maybe the first A should send request to the second B. Need not be in this way. Especially if the number are not the same, you can't have this kind of a routing. You need a different kind of routing. Do you have a router or a load balancer in between? When you split something across microservices, you need to handle failures. In a program, you will never have a case of one component being unavailable at runtime. With microservices, B can be down. How will you handle that? Not error handling, so much as failure handling. How do you do failover? If an instance of A is talking to a particular instance of B and that instance fails, how do you failover? Splitting things into microservices increases latency. Do you need prefetching? You'll end up writing a lot of boilerplate on both the A and B sides. There'll be more DevOps work, more deployment, because now you have to figure out how do you deploy each of these microservices. You have to monitor each of them in production, both black box and white box. Black box as in CPU, memory, etc. White box as in what's actually going inside it, the business metrics. When you have microservices, you could have versions queue of dependencies like, let's say, the JVM, if it's a Java program. A could be running one version of the JVM, B could be running another version of the JVM, and you don't want that. You want consistency. Or you could be using a different version of Django in A and B. You could even have a different language for B. Somebody might say, hey, it's a microservice, it doesn't need to use the same language. I feel this language is better for this task. So now that's double the work. So if you take a step back, you don't necessarily need microservices. What you need is modularity. You need a program as a whole, which is split into modules, which have a small surface area and communicate via well-defined interfaces. This communication need not be over a network. It can be on the same machine, same VM. And there are a lot of good programming practices you could follow. For example, you could have a facade, which is a class that hides a whole subsystem behind it. So in this example, you have all of these classes that are being hidden by the facade. And these are all package private. You can have modules in Java where multiple packages are private to the module. You could follow good guidelines on encapsulation, like my video which I linked to. In fact, I linked to my entire software design playlist. So you can follow all of these and many more techniques to have multiple pieces of functionality in the same monolith without interfering with each other. So start with a monolith. Only if and when you have a problem should you consider microservices. And when you have a problem, don't think, I have a problem, so let me switch to microservices. See if there are other solutions, simpler solutions. Stick with a monolith as much as possible.